Yes, it's visible now.
Yeah, so good morning, everyone. This is Jimmy. I'll host this MLP Week 4 SWI session. Okay, so yeah, so till in week 4, you studied about all those things like what are the different linear regression tools you have, like how you will explore the data and all these things you learn. Okay, so in week 4, I will in this SWI session I will try to summarize. I'll give some one. We will take one data set. Okay, and just we'll try to think like how we can help or how as a data scientist you will think. Okay, like what are the different kind of ADA you will do. Actually it will take like 3-4 hours, so we may based on the group space, we'll cut down few things. I mean, if we are able to cover all the things, then we will cover. Otherwise, yeah, we will skip some steps. It will be something like that only. Okay. uh, yeah, that's all I would like to say. Yeah, so everyone please open Google Colab. Okay, yeah, I'll share the link of the data set. Let me just stop. Okay. Everyone, please open the Google Colab notebook. Okay. Whoever came late, I'm just about to share the dataset link. So, it's taking a lot of time to open the dataset. Yeah, hello. Hello. Am I audible?
Yes, you are audible, sir.
Yeah. So everyone opened the data collab.
Yes, sir.
Yes, sir. Okay. Actually, I don't know, like my internet is there or what. I'm not. Uh, it is still loading. Like that. Yes. So yeah, the thing is, the data set belongs to some US car data set. Okay, so what is happening here is, I mean, would have some uh, data related to US market, and some new company. You are working as a data scientist in some new car company who wants to enter in that US markets. Okay, so they got some data from the other US companies like who is working to get the idea of that market. So the problem context is something like that. Just This is the link for the data set. Okay. Hello.
Yes, I got.
Yeah. Yeah. So I think I expect all of you knows how to load the data set. This was I was doing something. Yeah. So yeah, let's say you are working as a data scientist in some big automobile company. Okay. So your company aspires to enter the US market by setting up the manufacturing unit over there. Okay. So yeah, you have some data set, some data, and you have to based on this data, you have to predict the price of car in US market. Okay. So based on these things, yeah, you will be able to know, your company will be able to know like what are the different factors are there which affects the price of the car, and how iterating those things, and yeah, modifying those things, you will be able to manage the price of your car, and which cost segment you should focus, which segment you should not, something like that. Okay. All these things like we will try to solve. Yeah. Okay. So yeah, first step would be to import some important libraries. Okay. Actually, this last time only I ran this collab, so I think many things I had modified in this collab. So yeah, some new people are joining. Whoever is joining just now, so I would request them to open a collab notebook and just use this link to load the dataset. Okay. Is there anyone who is not able to load the dataset? Please raise your hand, or say, just message in the chat box, or you can speak also, so that I may help you.
Tell me once.
Yeah, to load the dataset. No.
Yes.
Hello. Yeah. So just open this link and copy your dataset in your drive. Okay. That's it. Just keep that. At least do that much. I mean, at least do this much. Just open the data.
So
Copy the
don't
data.
we have to use read CSV or something like that? Just
Yeah,
copy and read.
you can use that, but to use that, what you have to do, no, first just copy this data set in your drive. Okay. So that I mean, yeah, after this session also you can use that. Okay. First thing you can do that. Okay. Yeah. Yeah, the device shared the link again. Okay. So first just open this link and just copy that data set in your uh, drive. Okay. So once you copy that data set in your drive, then just mount your drive, and yeah, after that you can use that. I mean, yeah, pd.readscsv, using that you can load the data set. Okay. Yeah. And yeah, a few important libraries you can import like numpy, pandas, seaborn, and yeah, later maybe after certain steps you can load those things. Okay. But first step would be to open the collab notebook, just then open this drive link and copy the data set. These two things you have to do first. Okay. How much in detail we will go, it completely depends on you guys space. Okay. Because as quick and as soon as you guys are done, just a message in the chat box. Okay. I mean, data loading part. So yeah, in the meantime, we'll show the proper code. Yeah. Yeah, just whoever has loaded, just look the summary stats and all those things. Okay. Maybe in further step we will discuss that, then it would be easier for you guys. And whoever is still loading the dataset, no worries, just load the dataset. Okay. That is the first step, then only you will be able to follow it all of it. Anyone, if you are lagging or you don't know any step, please ask, okay? Because I want all of you to solve this one. So, okay, let's start again asking the questions. So, are you guys copied this data set in your notebook, in your drive? Anyone is there who hasn't copied the data set till now? Anyone, please answer. I mean, don't stay silent. No one is saying anything. Yeah, till now only one guy has messaged like he has loaded the data. Sujit has loaded the data set. What about others? At least 5 to 10 people should be there. No. Yeah, Jaydev is also done. Yeah, loading done. Okay, Depriya 3, 4 Chiranjeevi is also done. Yeah, thanks. Nah. Yeah, 6, 7 people. Yeah, that's fine. Yeah, now yeah. Let's wait for 1 or 2 minutes and then we'll proceed with this next step. So what do you think, like and whoever is done, just okay, Charles is just joined. Okay, I'll just send you the dataset link. Okay, in the meantime you can copy the dataset in your drive and just load that. Okay, or in the meantime let's start asking. I'll start asking some questions like how you will proceed or something, what you will do. Okay, Zadev, so can you speak or hello?
Who, me?
Yeah. It's okay because
Yes,
you are.
yes.
I think yeah. I know only you like who has experience in this field. Okay, so yeah, what would be your steps? I mean, what are the steps you will follow? Like what you will do first?
Primarily, I'll basically start looking at the distributions of different columns and see what they are generally like.
Yeah.
But if I wanted to sort of do this in one shot, then simple question to ask is what is it that maximizes the price of a car?
So what are the?
What is it that maximizes the price of a car?
Yeah. Okay.
But that's also not very smart because you could sell one car at high price or fewer cars at more price, a lesser price, that is. But since anyway we don't have any information about how many cars were sold as far as I can tell, so I
Yeah.
guess that simple regression problem would fix it. Before that, I will look at each column, try to, if it's a numerical column, look at the histogram. If it's a categorical column, maybe look at its value counts and see if there is obvious, if there is any obvious patterns, or if there are no patterns, maybe drop that column.
Yeah. Any other person? Hello. No, whatever you have learned, based on that, you can answer a few things. Okay. I mean, what are the steps you will follow? Like from here, like you loaded the data set. Actually, till victory, you have studied everything in like in pieces. You did everything in pieces, something like that. Okay. But here, I'll try to just combine all those things. So, any other person?
Hello.
Yeah.
Hi. So basically, I'm trying to get familiarized with the dataset. I'm looking at what are the features which are given with the car, with the data. Like what are the types? Is there any missing values? Like Vivek said, distribution of features.
Yeah.
Yeah, that's where I'm at right now.
Yeah. So yeah, everyone is aware of the problem, like what problem you have to solve. Anyone who isn't know about the problems? Okay, so whoever doesn't know the like first 1 or 2 minutes, yeah, you can see this is the situation where you are, where we all are now, right now. Okay, and then yeah, after that we'll start. Okay, symbolic column. Okay, I also need to check because like I also did revise this. I mean, the last time only in the last time only I just made this data set, all these things. But yeah, after that today I'm okay. Actually I was also traveling, so I was also not able to see symbolic. I think yeah, I also need to check. I had the all the details of the data set. Okay, yeah, I'll tell you. Yeah, so yeah, this is the thing we have for this data set. Okay, and yeah, since I have said it,
So we have to find the variables which will help in predicting the price of the car. So
yeah,
it's a
and
prediction linear.
yeah, and before doing that, we have to understand what data is saying, like what are the different parameters on which the data set is depending, which car model is like which car model is selling for faster, and yeah, which price segment people are like most number of buyers are in which price segment, something like that. All these things we have to focus. Okay, so yeah, these are so car symboling. It is assigned symboling is something, it's assigned insurance risk rating. Okay, it's assigned risk rating. A value of +3 indicates the auto is risky, and -3 that is it is probably pretty safe. Okay, it is something like that. Symboling is.
Got it. Thanks.
Yeah. So yeah, I think I should copy this part also. Anyone has any questions till now, or everyone is with me?
So there is a mention.
The sickly, sorry.
Yeah, please.
So what exactly independent variables? Like we already know that they are independent.
Yeah, you know now. I mean,
There can be like dependency between the variables also, right?
yeah. So that is correlation. So you have to check that, and
But it is mentioned explicitly that they are independent variables. So I'm confused.
so yeah. But we call it as an independent variable only. Dependent variable we call something like this one. I mean,
The price output.
yeah, your price. So yeah, your output here. Okay. So in that thing, like we call it as a correlated. I mean, as the in the seminar also they were talking like the heat and ice cream price selling. Okay. So yeah. Okay. So yeah, these are the dataset information you have. Okay. And yeah, how many of you know the curve weight and also these things are properly related to mechanical field? But yeah, we don't need to know all those things. Okay, this one is your price is only your dependent variable. Okay, price of car, which is numeric. Okay, so in the first step you loaded the data set. Okay, and yeah, this data set information you have. So yeah, I'm assuming that everyone has just loaded the data set. Okay, so now these are the questions. Okay, like first you have to do the data inspection part, and these are the question which answer I want. Okay, it's a pretty easy one, but yeah, everyone who has started just now, yeah, just see, try to solve just give answer of these 7 questions. Okay, just solve that. Okay, and maybe yeah, as soon you solve, you can put in the chat box like what is the answer you got. Okay, or maybe yeah.
Sir, can you
Yeah.
scroll up? Can I show the step 2 what we have? Yes, sir, yes, sir. Just yes. Sir.
See, you have to move on to the data drive, and yeah, this address completely depends on your where you have located your data set. Okay, it is something like just you have to open this one. See this files one. Okay, once you will click this one. Okay, here you have, and if you haven't written this code also, it will work. Like once you will click this one, no, your data drive will automatically mounted, and yeah, you will automatically get this code. Okay, and once you
Okay,
mount
sir.
your once you will mount this your data set, yeah, then click the drive, and yeah, my drive. Yeah, here you have your data set.
Okay, sir. Okay, thank you.
So yeah, are you done? Yeah, so yeah, first let's do the sum inspection part. Okay, object type is your, no, it is not always so. Okay, it depends on the situations. Yeah, let's. So how many data points you saw in the data set? First question will be that. Number of data points 205, 205. Yeah. So yeah, everyone is got, I think, yeah, first question. So yeah, now to check the data points, yeah, normally you have to see the data set dot shape. Yeah. So you have 205 data points, and yeah, features are actually 25 because the 26 is your dependent variable. Okay. So you have 25 features and 26 is your dependent variable. Okay. Which you have to predict. So here the counting is showing that part. I mean, counting is showing, adding that part also. Okay. And yeah, so Vivek is ahead of us. Okay. But yeah, we have to go with all the people. Like, so yeah, how many number of categorical features we have? So this is the third question. Okay. So first, usually what we do, like it's genuinely, I mean, whoever is new, I mean, the people who has already worked on data science field, so they knows. But yeah, as a common ES24 car ID is not valid feature. Yeah. Okay. So whoever is not aware, like yeah, first we say the shape and that yeah, usually we print the like first five and last five data columns. Okay. First five and last five uh, rows to check the data set, like what it is, like how, what are the different features, what are the different features are there to get a more understanding of the data set. Okay. So yeah, this is the like usual step we do. Okay. And after these steps, yeah, you can check the what is the dataset.info. Okay. These things usually we do. Yeah. So yeah, so these are the steps we usually see. Okay. So then yeah, just print that info part. Okay. To understand, like just you, since all the columns are 205, so we can check here also, like do we have any null values, or there are, yeah, codes are also there, dot is, and you can, using that also you can check, like do if you have null values or not. Okay. So but from here also, like we can understand, like since we have 205 total number of data points, and yeah, all the data points are non-null types, so yeah, we don't need to check that. Okay. So yeah, in the next step we are just describing, like dataset dot describe. So here anyone knows, like what does this mean, include all, and if we just remove this one?
It includes categorical variables also. If you put all, otherwise.
Yeah, exactly that is what it happens here. Okay. So yeah, now if you don't include all, then yeah, it just removes that categorical features, like, and also that doesn't mean for categorical features, what does it will give value for mean, and what value it will give for max, mean, something like that. Okay. So yeah, that's a good thing. And yeah, so the next question was something like how many number of categorical columns we have. That was the question only, no, like how many number of categorical features we have and how many number of numerical features we have. Okay. So yeah, in general you can directly count, for since we have less number of I would say less number of features. So but yeah, we can use the codes also. Okay. Dot log and dot ilog can help you, and also you can plan some, you can use a loop, like you can use for loop also, like where you have this object type. Okay. All those things you can do. And here I think I had taken, how I had taken, like think, let me see also. Yeah. So anyone till now facing any issues, or you guys done till now? I mean,
Sir,
yeah, hello.
sir, how to load the data? I am unable to load the data. You said that you get that collab code automatically. Sir, how can we get? Can you explain?
Okay, just let me. Okay, I'm just unmounting it. Okay. 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 Yeah, it's this topic only. It's yeah. So first you have to connect this one, okay? And once you connect it, just first thing is that you can just write this code, okay, to mount your drive. Or if you haven't mounted that,
Sir, how to mount? First, you click on that file, then what we should do?
so on that link you are saying,
Yes, no. At the left side, there is a file here. So you click on that, then what?
okay.
should we do?
So third one is noting your drive, okay? If
Okay,
you
sir.
click this one, no, directly also you can mount, okay?
Yeah, I have mounted that. Then what is next
Okay.
step?
Okay. So yeah, let's say, like mounting the Google Drive. Okay, let me mount this one. Okay. Or you can just run this code also. I mean, yeah, from Google.colab import drive and drive.mount. Okay. So both things will do. So okay. So now have you saved your data set in your
But sir,
drive?
I didn't get that code from where you said that you automatically get that code now from Google.colab import drive.
Yeah.
Actually, I have to type this code or will this automatically?
So are you have you actually I haven't tried using directly clicking this code one. You used to write this code only. So
Okay.
I think yeah. So any one step you do know that it will work. Okay, that will work. So if you have loaded this your drive, so obviously this cut mark sign will be there. Is it there?
Sorry, sir.
This line will be there on the drive.
Yes, sir. Yes, sir. I have mounted that.
Yeah. Okay. So once you will click on this drive, and maybe on my drive, are you able to locate your data set?
No, sir. My drive, in my drive.
Okay. In my drive, you would have the data set. Okay.
This
So
is
let's
car
say,
data set, like, no?
yeah, car price in US market. Okay. So, or if you have directly saved it, no, then you have to write. It's just its location will be something like this. I mean, yeah, this one will be your location. Okay.
Okay, sir.
Okay, but sir. Here I have just created a folder named dataset. So here I have kept this dataset. Okay, this car pricing. So when I'll click this one, yeah, I would have option of copy path. Okay, so just copy path that, and I can show that.
Okay, sir. Okay, got
Yeah.
it. Thank you.
Thanks. So yeah. Okay. Let me again. I have to. Yeah. Before that, you have to run this. Basic. You have to import basic libraries. Oh. Okay. I just remove this one.
That should be only content and then.
Yeah.
Drive and my drive will not be there.
Yeah,
Link,
it depends like
yes.
where you have saved your data set. Okay.
Yes.
Yeah. Yeah. Actually, I just I had saved it in data set, so that's why it was missing. Yeah. Due to that, it was missing. Now it is loaded. Okay. So whatever is the location, it depends on that. Okay. So do we have to count the categorical feature from describable? No. We can write the codes. I would have written like I have to see also like you can just like you can do the for loop. You can run the for loop like whenever the you have it it is as object type. No, you can save it something like that. You can do, and there can be many type of code. Yeah. Or maybe let's say yeah here also like if you are seeing the describe include all whatever is the number of columns this one gives include all. I mean you can create any logic like using that logic you should predict the data if we will give the count. Yeah. Okay. So yeah. Hello.
So you said that to count the number of object features to get the category value, but it's not mandatory that the feature category feature is only object type. There can be feature that has one or that is integer values.
Sorry, I am not able to hear you properly. Can anyone did anyone understand like what he is saying, or maybe you can type in the chat box. Hello.
I'll type in the chat.
Yeah. Okay, so yeah, so our goal was to just what I did here, like I set, I loaded all the feature, I saved all the column names in a variable named features. Okay, so now we have this one like features. It is nothing but just it has saved all the features. I mean, what the name of all the features. Okay, like car ID, symboling, and all we have here. Okay, so yeah, we have to check also like a duplicated data. Okay, so do we have any duplicated data? So yeah, we just check the length of, okay, like how many duplicate data we have. Okay, so can anyone say like why we check that like duplicate data we have or not? And if we have duplicate data, then whether our answer will change or not?
It will not change, but it will impact the performance. Like processing will be more required.
Exactly, that is the issue. Base. Yeah, so yeah, unnecessary time will be more time will be taken, and yeah, so computing time and cost obviously of resources. Why to waste that if the data points are giving the same information? So it's not good to keep that. Okay, yeah, so after this, yeah, now we have to move to the EDA part. Okay, like how many numerical features we have, how many categorical features we have. Okay, all these things, like how many which kind of distribution our dependent variable follows, like we can plot different graphs to understand, I mean, to get the insights. Okay, and we will try to do that. Okay, like I also like this part. I mean, let's see like how many type of how many insights we are able to able to get using the different graphs and all. Okay, so it's a good time to see like how many states you have how good, how much I mean, have you learned only stats part, or you are able to understand that, I mean, to gain some insights. Yeah, okay, let's say start. Okay, so yeah, anyone just start writing the code. So for yeah, list of all numerical features. Okay, and one thing I would say, like whatever the question I should know at the steps, like what these 6 question, in all the OPs these questions will be common. I mean, there would be few marks and 7-8 questions will be like that only. So those are 3 marks for OPs. And but yeah, I would say don't do mistakes in those steps. I mean, those are free marks. And yeah, and if you do any mistakes in initial questions, no, then yeah, all the questions will be wrong at the later stage. So yeah.
Sir, here your feature, that names of features, it also includes the label price, right, sir?
Label price.
Price is a label, right, sir?
Yeah, price is a label. Yeah.
So here the feature includes that as well, right?
No, here I just give the name. No feature.
Okay, sir.
Yeah, it's not like it is available. I just give that variable name as feature. Like the features are like all the name column name. Okay.
Okay.
Something like that.
Okay, sir.
Yeah. Okay. So yeah, these are our next questions.
Sir, can
Yeah.
I ask a question? Yeah, if there is duplicate values, how do we remove them?
If it is duplicate, no, we can drop that. Okay.
Do we drop the rows, right? So how?
Yeah.
So we change the access. That's about it.
Yeah. Sorry, what you said?
In the drop function, we have to change the access, right? Or how
we have directly code for drop duplicated. Yeah, as Jaydev mentioned. Okay, df dot drop duplicate.
So that will drop the rows, right?
Yeah, yeah, it will drop the rows.
Thank you.
Thanks. And if you want some longer path, then yeah, you can run the loops. But obviously, those are not a good idea. Like for 200 data points, yeah, that may work. But for longer data points, that won't work. I mean, you have to use these codes only, like df dot drop duplicates and all. Okay. So yeah, you have to see all the, I would say, yeah, all the numerical features. Okay, so what I have done here is like just simply data set or describe. Like as we know that if you won't add, if you don't add include all here, so then it will give you the list of all the numerical features only. So we can save that, okay, in some variables. Here I have saved it in a numfit. Okay, so yeah, these are our numerical features. Okay, anyone has any issues in that, and are you able to follow me till now?
Jimmy, car ID is not a feature. That's the only thing.
Yeah.
Otherwise,
That's true. That's true. That's true. I mean, yeah, we should actually, we have written our code something like that, so that's why it is showing like that. Yeah.
while loading the data, we can set the car ID to the index, so that way it will not come up in the array.
Exactly. That is what I should have done at initial steps only. Yeah, the point, whatever he has pointed, that's correct. Car ID is not a features actually. It's just
And
a
how
symbol.
would you do that, sir? That converting it into an index?
See, first thing what you can do here is you can set your columns from here only. I mean from symbolic, and there is also option like reset index and all. Okay, you can use.
We can do a dataset.set index of car ID. It will get dropped from the data frame and it will come in the index.
Yeah, that is also a method.
But car ID is not indexing properly, because if you see the head, it's going 1, 2, then 3, then the column 3. It's not indexing as per Python. It's going by starting from 1, not from 0.
Yeah, it's okay. No, I mean it's just an ID, and any ID will work. If it is unique for all the columns,
As long as there are 205 unique values in it.
Yeah.
So what is the correct procedure? We should index as per Python this thing, or should we index as per the
anything
start
will
from
work.
1?
See, anything will work. I mean, if you have any IDs number like a NAP something, NAP2, T3, something like any kind of coding, that's okay. I mean, if as long as those are unique. Okay.
Will it be better to drop car ID and take the?
Yeah, in this case, the simplest thing to do is drop car ID.
Yeah, you can do that also. As I told you, like if in the initial step, if that it would be your index, then yeah, you can use reset index and you will get this type of index. So if you are getting confused, yeah, you can do that. Anything will work. That it won't matter much. I mean, these things matters much in that case. Like when you have to map your, let's say, like if you are working on some data set which belongs to some person. I mean, yeah, and they have their IDs, and you don't want to show to some other companies. Okay, then you have to map. I mean, let's say like here this 4 represents Audi car. Okay, so now this 4 has meaning, and I have that. I mean that Audi car, whether it belongs to Audi car or something like that mapping. We have some other columns, or we have some other tables where we have mapped the data set.
No, I was thinking in terms of if we want to drop certain row, then what index should I take? So in that context, I was thinking.
Okay, still if you have dropped that some rows, no, then still you have to keep. I mean, what will happen? I have 1, 2, then 4, 5, something like that.
Yeah, got it.
Yeah.
So I'll have to just remember what I'm taking as the index. Right.
Yeah.
Hi sir, I am not clear like how did it filter out only the numeric columns?
This one?
Describe, yeah.
Yeah, so what happens here is last time, that's why I have written include all there. Someone would have asked the same question. So yeah, see here when we add here include all. Okay, so are we doing mistakes?
It's the other way around.
Other way around, yeah.
Okay. Oh, are you guys seeing like something like that? Yeah, that's perfect. So what is happening here? I think you guys are seeing. You are able to see here. See,
Yeah, got
car
it.
ID symboling. Like now currently we have all the features. Okay. So when we remove this, no, including all. So by default it is set to false. Okay. So then it will give you the result for all the numerical columns only.
And what about if I just want class variables,
Sorry.
like non-numeric variables?
So that you can do here. I mean, see, you have the all the features name, okay, and you have got the features name which are numerical. So once you subtract these things, no, you will get the all
Okay,
the
so there is no
categorical
direct
column.
method. Fine, fine.
Yeah, there is some direct method. I mean, any logic if you are able to make, no, I think I have used in some other collab also.
Yeah, fine, fine. We
Yeah,
can
yeah.
proceed. Yeah. Thank you.
Yeah.
Sir, when
So
you did that describe all, it showed some columns wherein there was a nan given. So
yeah.
Doesn't that mean that it is a null?
No. The thing is, nan was given for those columns, like for categorical columns. What is the meaning? What value it will give for mean? For categorical columns, yeah. What would be the standard deviation also? So for that, it showed that nan.
Okay, sir.
So yeah, these things were there. Okay. So now let's start the plotting the graphs and all. Okay. So maybe seeing those graphs, we would be able to predict some few things. Okay. So here we are seeing that this part, I mean car ID, yeah, obviously it is unique for every car. Okay. So yeah, it is it won't give you any kind of insights. Okay. Now let's see symboling. Symboling is from it is ranging from -3. We don't have any, but yeah, it is ranging from -3 to 3. It was something like that. And see, we are able to see here like most of the symboling belongs to 0. Okay. So what was symboling? It was related to car insurance. Okay. Whether it's a pretty safe or not. -3 was pretty safe and 3 was not safe. Okay. Insurance risk rating. A value of +3 indicates that the auto is too risky. -3 is probably pretty safe. Okay. So yeah. Again, this is it label encoded or what kind of data it is? So first question would be that this symbolic, these features. Anyone?
Sorry, what is the question?
Ordinal, right?
So what kind of features?
Yeah,
Ordinally encoded, right?
Yeah.
It's
So,
like discrete data, not a continuous.
Yeah, it's a discrete data, but yeah, as I asked you, like it has meaning, no, just as you said, like it's ordinal. I mean, it has meaning. Like one is it's less risky. 3 is more
Ordinal.
risky. Yeah, exactly. So that is what I wanted to know. Okay. So yeah.
Sir, could you please help us understand this plotting code? What does that bins show us? Bins are the number of different places the histograms are there.
Bins are these counts. I mean, how many counts we want to plot? Okay.
Okay.
Yeah, that is the bins, and figure size like what kind of shape you want. Okay.
So
and
figure size, sir, it means the entire figure or each of those histograms?
It's like an entire size. Okay. And why don't we should iterate that? No, I mean the whole size. Let's say it 10 by 10. Okay. Let's see what happens. I mean, all the plots will see. Now the size is something like this. Okay.
Yeah. Yes,
how do you determine the number of bins? I mean, do we always take 50 or?
No. It completely depends. Like, I mean, how much clear data you want. I mean, how big figure you want, how small figure you want, something like that. These things can be set by you. So
okay.
Yeah.
So if you just put 100 and can we have a look? Sir?
Yeah.
100.
That will also work.
But note that you have only 205 data points. So
yeah.
Oh, okay. Okay,
I think you
thanks.
should
Got
like
it.
look at how the distribution comes out, and like if it's too sparse, you should decrease and stuff like
Okay,
that.
Something like this.
okay,
Okay. So yeah,
thanks.
this is going to be more dense.
50 is not clear to me. Like for symboling, it is -2, -1.
Yeah.
And for wheelbase, it is 90, 100. So where like that 50 or 100 is playing the role?
So that 50 or 100 is playing the role. Let's see the thickness of this one, these three. Okay. How thin it is, like that column, that blue column, how thin it is. Okay.
Okay,
So
okay.
so basically it is planning to keep like 100 sticks like that in between these tables. Okay. Bins, maybe in other graphs I would be able to show you this bins further. Okay. Because there you saw no, like if I'll set this as a 10. Okay. Like these things will be thicker. I mean, see, now you are able to see this one. Okay. So now it is the maximum 10. Here we can easily count, like car ID is unique. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total 10 we have only. Okay. So it yeah.
So, so by beans, it is just a bucketing, like starting and the ending point of each value. Is it like that? How we are bucketing the values of each?
Uh,
Yes, it's
yeah.
number of buckets.
Yeah.
Minimum value and maximum value will be divided into n bins, whatever your n is. And it will
Yes.
simply
Yes,
count
that
how many
is
values
applicable
are
for
there.
each and every graph.
Yeah.
Okay.
So yeah, anything you can set, like I mean, as long as you are able to clearly see the patterns, no, that's well enough. Yes. Okay. So it's okay. Just skip this one. Okay. So now, yeah, let's start seeing this part. I mean, our independent variables. I mean, okay, I have plotted in. Yeah, it's actually a dependent variable. Yeah, the price it is no. Yeah, it's a dependent variable. Like what is the graph of this one? Okay. So just see that if you are seeing this kind of shape. So if you want to make it little thin, so yeah, you can set that. I would say this part means you can set that at a smaller size. Okay, something like that you can see. So here you are able to see like most of the cars price is around 1 lakh. Okay, it's a $10,000. No, yeah, 10,000 US dollar. Yeah, most of the car price is around 10,000 US dollar. We don't have, I mean, somewhere around like after around 8,000, we don't have any car price lesser than that. And most of the, and we can see the density like in the left side. In the vertical column we have density, and in the horizontal axis we have prices. Okay. And we are seeing that yeah, maximum car price is around 50,000 US dollar, and there are very less number of cars near to this price. Okay. And most of the cars is around 8,000 to around 20,000.
So
So
can you show the code once again?
yeah, this one, yeah, there can be many a number of codes. I mean, yeah, in any ways, in any case, like you have to
Distribution plot gives the
yeah.
density.
Yeah.
Dist.
Yeah. Dist plot it is actually. Okay. So see here, what we are able to see here. No, I mean, see, based on this graph, what kind of suggestion you would give to your company? Let's start discussing that. Okay. Based on yeah, we saw this price, and yeah, what kind of suggestion you would like to give your company?
So obviously, like around 10,000 US dollars maximum sale is done. So which market they want to target, like low end market or high end market? So my first question will be like which market you want to target. Based on that, we will suggest the pricing.
Yeah, here are two things we can say. First thing is like yeah, around 10,000 US dollar we have lot of competitions, but yeah, people are also very likely to buy this to buy these prices car. Okay, but also we can create two strategy. We can create some obviously I mean the high prices car, and but there are very few people I mean buying. If you are creating some high prices car, then we should focus around somewhere around 35,000 US dollar. Like we are seeing the yeah larger number of sales and all. Okay. Or yeah, any other suggestion or any other kind of strategy?
Excuse me, sir. I have a doubt. So there, we don't have the sales data, right? Like we just have like there is a number of cars in that price range already existing in the market. So can we actually give that suggestion?
Yeah, sorry, just repeat what you said. I mean,
So we
That's a
don't
good
have
point.
any information about sales. What
okay.
we have is there is a number of cars which are produced in this price range.
So
So
yeah.
we cannot really say that suggestion like we just discussed, right?
Oh yeah, the thing is here, we are what we said
Based
like.
on this, we can't answer questions like how to maximize sales.
Yeah, no, we can't say that like how to maximize sales here. Okay, so the thing was there something like on road cars are there like around 200 500 cars. Like we have some samples. We took the some samples from the market, like how many cars are there and like yeah, what maximum cars we are seeing. And these are the basic themselves like your data is representing the population, something like that.
So this density is the probability.
Yeah, this density is the probability. I mean, yeah, how many percentage of
Probability.
cars?
So
Yeah.
the higher probability of the range of $10,000, right?
Yeah, higher number of cars are there around 10,000. It is something like that you can say.
Okay.
Number of models in that price range exist in the
Yeah,
market.
In that price range. Right?
yeah, exactly. Something like that you can say. Okay, or yeah, any kind. I mean, I don't have any hard and fast rule like yeah. These are the suggestions we have to give. Yeah, we can get some insights. I mean, whatever you insights you will say, yeah, something like that. Also, I am thinking something. So it's not like yeah, whatever you said is correct or whatever I said is correct. Okay, so yeah, we have
The
to just
distribution plot, it looks like a mixture of three Gaussians.
yeah.
If you can split that and figure out what are the characteristics of each of them,
Yeah.
that represents the market, sort of.
Yeah, something like that we can do. And as I said, no, like here only the main comes like your human intelligence part. Okay, so you can think about any other method, any other process, and yeah, how you can get some more better insights, something like that. So yeah, I just try to introduce that part. That's it. I mean, okay, so what we did here is like we just use that log space. Okay, I mean, instead of plotting it directly, we try to plot it using the log part. Okay, so to see that like since it was skewed kind of shape, no, so to just make it as a like a proper bell curve shape. Okay, so we try to normalize the data. Okay, it's okay. I mean, it doesn't give it large meaning here. Okay, so let's go to this question set 3. Okay, so have you read about this VIF part?
Sir, I have a question.
Yeah.
So, sir, we have to use a statistical knowledge by just visualizing these curves and recognizing, like Mr. Jadev mentioned, that these are a combination of three Gaussians, and we can just independently read about the things of these Gaussians, how the things are
Although
going.
keep in mind that it looks to me like that. That's my hypothesis.
Yeah.
I'll have
Yes.
to go test it.
Yes, sir, obviously, but is it how to approach, how to do things, to use our statistical knowledge using these curves and
Exactly. In these cases, only your statistical knowledge will come. No, will come to help you. I mean, how you can interpret these things. I mean, for others, like it's just a graph. I mean, if you are in 6th standard, what is this? It's just a shape and nothing else. So as you increase, why do we use the log function? Okay, I mean, I would have plotted like last time I didn't clean this collab. Like last time, even I don't know like in the last time what I was discussing here. Maybe just someone would have asked us to like how we just standardize this data set, something like that. That's why I would have plotted it. Okay, actually I was traveling till yesterday. I was traveling, so yeah, I just simply took the like last time I have used this collab for SWI. So yeah, that's why there are a few things. I mean, I did yeah cleaned it. Okay, so yeah, that's why I mean you have to that EDA part. No, I mean see the finally the making the model is that's not a big thing. I mean, making a model, that's not a big thing. The main part comes here only. I mean, you have to frame your normal questions to, I mean, data science problem, then how just interpreting these graphs and all these analysis and all these things takes a lot of time. Okay. And yeah, these things comes from your experience and all. So as they said, no, I mean, recently we had a meeting, I mean, in the college only, like a few people, a few professors from IIT Bombay were there. So we, I mean, obviously, we all, a few of us were from ML background, but few of us were from the like mathematics background and all. No? So he was suggesting the same thing. I mean, they were saying like what computer science people knows. He doesn't know. I mean, he knows some code and he doesn't have any other knowledge. Okay, but you guys are the main. You guys can easily go to in the ML field. You should learn. I mean, you have all the things like you knows maths, you knows the stats. So obviously, you have to learn just few lines of code, something like that. So yeah, that is what reminding me of this. I mean, yeah, these maths and all these things will help you, and you have to learn. Just for I will okay, you guys just continue with these three questions. Okay, I'll start with like I'll be back in 2 to 3 minutes. Okay, or 1 to 2 minutes. Just read these four questions. Okay. Hello. Okay. So anyone facing any problem till now? Hello. So hello. Am I audible or what?
Yes, sir, you are audible.
Yes, sir, you are audible.
Yeah. So yeah, that is what I'm saying. Sir, have you read about the VIF factor? I think you haven't read about that.
No,
Okay.
sir, we haven't.
Yeah, it's okay. Okay. Just leave these three steps. I mean, you could have done this part, but it's okay. Just okay. Just do one hot encoding on features like car body, engine type, and fuel system. Like whatever the type of you see the categorical variables. No, just do that. I mean, just use the one hot encoding. Okay. Hello? Are you guys able to do or should I help? Hello. Anyone. No one is replying. Okay, I'll just skip two parts now. Yeah, see, first thing is there. Okay, so do you guys know how to plot this heat map? Hello? Hello?
Yes, you're audible.
Yeah. So do you guys know how to plot the heat map and all? I mean, whoever is just new, obviously whoever knows this thing, whoever worked as a data science and all, they knows. But yeah, new people. So see, get shy. Okay, I mean, yeah, people knows that's a different thing. But you guys are new, and whoever is new, mostly these senses are most helpful to them. Okay, and yeah, we are creating these sessions to keeping in mind those people also. I mean, whoever is completely new. So that's why we are discussing the basic things. I mean, how to load the data. I mean, yeah, how to do the initial steps and all. Otherwise, there are many things which currently I am skipping in this collab. Okay, when I created this collab, I had many other things also in my mind, but I'm just skipping those tough steps just for the purpose of like new people, so that they can understand the basic steps. Okay, and
Would this collab be shared?
Yeah, but not complete, I would say.
Okay, so then I would suggest you explain the steps of the heat map one.
Okay. So yeah, so the basic things before you're doing I would say before doing all those parts, you have to just clean the data set, then you inspect the data set, and you made your data set in such a form so that you can apply the models. I mean, there are many models where you can. I mean, I had asked in the last session also, like you have to read about the like what are the different assumptions of linear regression. I mean, why you can't those assumptions like when your column when your data set follows linearity, homoscedasticity, and all. Okay, so like why you should normalize the data, and why if the two columns are highly correlated, then you should not keep one of them. These things. Okay. Okay. So you had to read about all those things. Okay. So let's start with this.
So I have one question.
Yeah, please ask.
We don't we don't do any analysis of any outlier which may affect the regression.
Yeah, we have to do.
Okay.
We have to do. I mean, if we have outliers and you are seeing that what happens, like you just create see the basic steps are something like that. You just clean your data set, you make it usable for your model, and then just train about your model. Okay.
Right.
After creating your model, I mean, you saw your scores. So let's say like as Jaydev is saying that R2 score, you saw your R2 score, and now your target is to how you can improve that score. Like that is just your baseline. I mean, now your target is how you can improve. Maybe use some other algorithm. Maybe just do some feature construction part. I mean, yeah, you saw that, yeah, we have outliers. Just remove that. Then see whether your scores increase or not, something like that. Then you start doing that. Okay.
Right, sir.
Yeah, it goes like that only. And yeah, many things you can do. Those things are, yeah. So to plot that heat map, the heat map and VIF, both things are useful to remove the highly correlated variables. Okay. VIF is also variance influence factor, that is also we use to remove that highly correlated factors. Yeah, high correlated features. Okay. So how it will like usually what we do is like we just calculate the VIF all the columns, and we see usually like whose VIF value is more than 5 or maybe 10, then we remove that. But yeah, one at a time, and then again rerun that. So
what is the code for VIF, sir?
Yeah, it's just that this one. I mean, simply here like we can import this library. Okay, very simple factor. I mean, yeah, we can import this API. Okay, and this code just we simply wrote to just make this data frame. Okay, so just for easier visualization, nothing else. Okay.
So you said anything over 5 has to be removed.
It's not a rule. It's a general practice people follow.
Okay. So here VIF is coming very high for all of them. Sir.
Yeah. So we have to remove one, then again to see that. But I would say like after removing all the VIF more than 5, we were able to see that just 2 columns, I would say 2 features. So the main thing was there, like we had only the 205 data points. So that's why it was happening, something like that. Okay.
Okay.
Yeah. So ideally,
But maybe they are the most important in determining the car price.
yeah.
When it could be a possibility also.
Yeah, that could be a possibility also.
So what is the theory behind VIFs? Or should we just Google and see?
Yeah, I would say just Google and see, because I will also tell like in few 4 sentences only. But yeah, it would be better like if you see use Google on this.
So broadly, it is just measuring the correlation between the factors, the variables.
Yeah.
Okay.
And, yeah, to see that it's always a good practice. I mean, just you have to whatever the steps till now I have discussed, no, that you should use in all the collabs. I would say like with all the data set. I mean, you have to check the null value, you have to check the duplicate value, you have to see the data set, like what are the different columns are there, what are the different numerical columns, what are the different categorical columns are there. You have to check. Okay. Then the next step comes to like you have to plot the heat map to see the exact correlation. That is also a very important step. I mean, every time we do that. Okay.
Right.
So it's just like a simple thing. I mean, these statements, just what these statements are doing, it's simply setting the figure size. Okay, like how much long and like how much length and width of figure we want. Okay, it is setting like the SNS.heatmap too, and here we are using that absolute correlation. Okay, so what does it does is like it won't provide the sign of -1 and +1. Okay, it is just it will plot it will write all the correlation value between 0 to 1. Okay, it won't put like -0.8 or 6. Okay, so that's why we have used that absolute. Okay, annotation is true, so that yeah, we see that all the values here. Okay, and yeah, color you can change. A cool warm is there, hot is there, jet word is any colors. Okay.
So we can remove the collinearity between the features from looking at the heat map also.
Yeah.
But
Yeah.
we'll have to set something that anything above 0.85 we should remove.
Yeah, something like that you can do. I mean,
okay.
these steps you will do like when you see when you will try to improve your score. Okay, just try.
Okay.
I mean, just try and check something like that. Hit and trial method. I would say. But obviously, most of the times, what happens? You know, like if you have two features which are highly correlated and you don't remove that, no, then you are what you are doing is you are giving very high weightage to that feature. Okay.
Right. Sir.
So yeah, that's not a good thing. Okay, so here we are seeing that yeah, car width and car length is highly correlated. I mean, so the correlation are around 0.84. Okay, and yeah, something like that. I mean, yeah, let's see.
So in this map, shouldn't we remove price because we want the high correlation with price?
Yeah. We can.
Okay.
Yeah, or maybe here if we are keeping this one, no, then we are able to see also like this is also a good case.
Yeah.
I mean,
right, sir.
Exactly, we can see. I mean, how much lesson it has with other things. I mean, here also we can see like a car width is highly related with the car price. I mean, this thing, engine size, the relation with price is around 0.7. So, I mean, higher the engine size, higher the price. It is giving a very good idea. Okay. 0.7 is there, and city MPG, yeah, how much mileage it is giving in the city. Okay. These things will be very useful. I mean, here, and yeah, we can see that to create the car, you can see that like what are the from here also like you can get many insights. Okay.
Sir,
Yeah.
I have one question.
Yeah.
Sir, in this heat map, do we have to check the relation of price with other features only, or do we have to check also that the correlation of features among themselves, and how should we should calculate, or how to know how many columns which we should keep and which columns we should drop off maybe, so using this correlation.
Here, as I told you, here is the two things. Okay, first thing is for your understanding. I mean, see, if someone is from mechanical background and who has knowledge about car, they can simply understand like, yeah, this is obvious. I mean, if more is the engine size, more would be the price. Okay.
Yes, sir, that I understood. Yes, sir.
Yeah. So this is for your purpose. Okay. So, but if you want to remove that highly correlated features, so for that you don't need price. As he said, I mean, whoever was speaking earlier, he said like we don't need like
Can you just scroll a bit to below, Jimmy, just so that I can see the ticks of the bottom axis and maybe zoom out. So, or maybe just open this in a new tab. Okay, this is, I think, no, we just need to see the labels on both axes. That will actually make it easier.
yeah, actually the same labels are there. Why you saying something like that?
No, zoom out, not in.
Okay, sorry.
You see, all of the size related things like weight, height, and width of the car, they correlate very highly with the price.
Yeah, is it here now?
City MPGA and highway MPG is very highly correlated.
Okay, that is the mileage in city and highway.
Yeah,
Okay.
yeah.
Yeah, so both are mileage only.
So is there a way to remove the upper half along the diagonal so that it will be easier to, because this heat map is very, very
Okay. Yeah, actually there are many columns. No, so yeah.
Yeah, so if because the upper half is a repetition of the lower half, so it's
Exactly. Yeah, that's true. I mean, whatever you said, yeah. I also need to check that. Do we have any codes? Yeah, many insights you can get from this tables. I mean, sort of like even without being from that background, yeah. So your question was something like that, no? I mean, yeah, these features should we see that price? Yeah, for price you should see this for your understanding, and yeah, you can make the correlation. You can see the correlation of different features. Okay, just seeing these two. Okay, and yeah, the number, how much it is getting, and if you are seeing that higher number, okay, just remove that and just see like how your model is performing after removing one of the features. Okay. So here we are seeing that here just see as is said no like city MPG and highway MPG. So more or less both are showing the same thing. So it would doesn't it would be a good idea. I mean I just combined both the features. I mean let's say like we will make a like mileage features, new mileage features, and we'll combine both the features. Let's say we give the high weightage to city MPG or lesser weightage to city MPG, and yeah, giving some weightage to I mean, let's say what I would do like I will give 70% weightage to city MPG and 30% weightage to highway MPG, and I'll combine both the features and make a new feature named as average mileage. So something like that I can do. These things comes under the I would say yeah this feature construction part. Okay, and like that from where I got this idea, I got this idea from this one only, this correlation this table only. Okay, it's nothing come directly, something like that you can do. I mean if you are you have to reduce the features also, no? That would help. I mean let's see here only like we see we are seeing the car length is there, car width is there. So why would I keep both the features? I would simply convert it in car area, something like that. I'm just simply saying I am not yeah. See, let's see. There would be like what is the this car length is there? This feature car length. Yeah, 0.84 is like yeah. Correlation factor is 0.84. Okay. So yeah, we can combine both. No, I mean we can create a new feature named car area. Okay, you know curve weight. What is curve weight? Curve weight is nothing but just the weight of the car, like when it's completely empty. Okay, so that is also at a very high extent. It depends on this thing. I mean, if I'll make the car area, no, it will be car length, width, and height. It will multiply these things, these two things. You know, it will be highly correlative with this curve weight. So yeah, like that we can reduce the features. We can create some new features. Something like that we can do. Okay, and just see here also, like if the engine size is high, then obviously horsepower will be high, because obviously the more is the engine size, more is the power. Okay, so these things you can do. I mean, let's see here also this table is, and Engine size is highly going to be covered. It is somewhere around 0.81 horsepower. Okay, so something like that. You can just by seeing these things, you can modify your data set or modify your features. Okay, and anything else any other questions you want to ask from here? These are the steps you have to do. I mean, I would say, yeah, these are the compulsory steps, something like that. And these colors I wrote just for the purpose. I mean, when you will change and all, no, you will be more comfortable with the data, something like that. You will be more comfortable with the code actually. So that's nothing important in these things. Okay. Yeah, I think that was it's okay. So yeah, these things you can do to check the all the unique car names. I mean, how many car you have different. So actually, we had many cars. Okay, I mean different brand, different models. So it's okay. We'll just do the. It's already 12:24. So let's move to the model making part. Okay. I mean, yeah. So I think had you done that part, I would say what you will say that convert to the one hot encoding. Had you done that, or EDA part is still we have a lot of EDA we can do, like we can plot the bar plot, and yeah, we can see what are the, I mean, see, like most of the cars are front wheel. Okay, in the near the front side only. Okay, very few cars are there in the town, like which has the engine at the rear side. Okay, so these things also comes from the, like I mean, here I have done the value count, so we can plot the bar plot also to see that. Okay. Hello. Hello.
Yes, sir.
Yeah, everyone just I felt like all are sleeping. Okay, so it's okay. I have done so many things. It's okay. Let's move to the next part. I mean, just simply try, just split your data set. Okay, let's leave all this part. I mean, yeah, I'll skipping these things. Okay, let's do that part. I mean, yeah, split your data set. I mean, have you converted all the columns and all? I mean, hello.
What's it?
So till now, have you converted your data set? I would say, I mean, in your data set, have you converted all the columns which was uh, categorical into the numerical columns? I mean, you used one hot coding and all? Hello?
No, sir.
Yeah, still it's okay. Then otherwise, I would say, yeah, let's keep it simple. Since 25 minutes. Yeah. So just take these two columns only. It's okay, leave it. Okay. Just take the engine size and compression ratio, or just drop all the categorical columns. Okay. Just drop all the categorical columns and try to build the model. Hello. Are you guys not getting my point or something? Hello.
Sir, these are Z score for engine size and compression ratio. These are Z score. What is this?
Just don't think about these things. Just think like you have the columns. Okay. Let's see from here. Okay. So there are a lot of things to cover and it's not that clean. So here you have your data set, okay, and you, as you saw here in this data set, most of your columns are I would say categorical type only. Okay, so after using the VIF, actually what had happened is, no, after using the VIF, I had kept these things. I mean, I have kept a few columns which was available. I mean, which variables are there? Like engine size and compression ratio was the only variable which was at the end. Okay. So yeah,
Yes.
we trained our model using these two columns only. Okay.
Okay, sir. Yeah.
So yeah, these were your new columns, and yeah, now you have to make a new. You have to train your model using these two. Okay, using these two columns. Here also like few system are there. So do you have of you have the understanding like what is MPFI to BBL?
Yes, sir. MPFI is multi-point fuel injection, I think.
Yeah, that's correct. That's correct. And what about other? I mean, yeah, I know just one thing. Okay, yeah, these are the different fuel systems. That is what I also. And okay, there is actually I don't want to deviate. I just want to cover all the things. I mean, there are a lot of things. I mean, I wanted to cover the region regression, lasso regression, normal linear regression, all kind of things.
Yes, sir. Plus, sir, if possible, please can you share this collab, sir, so that we can properly understand.
Okay, yeah, I think I should do that.
Sir, we cannot ask everything from you, sir. This
Yeah,
will take too much time. We have doubts actually, but if you share this so that we can properly observe what is going on, what is the code here.
Yeah, I'll do that. I mean, I'll put it in the more clean form. I mean, whatever the steps. I think I had done many things. I mean, last time when I started doing, I also didn't know like this was the first. I mean, in the last time also I took this HWSN first, and I didn't know like how fast I can cover that. So I thought I will cover all the things. I mean, yeah. After that, I had made a few things like different model price, like what is the price range of different companies' car, something like that. All this kind of video was there. So I removed all those things, and after that, I was not able to clean that. I mean, for this time, I didn't clean all those things. I mean, yeah, I did many steps. I wrote new steps in the middle of the collab and all, and yeah, this is completely messed up.
Okay. Yes, sir. Yes.
Yeah. I'll clean it and I'll put it properly. So yeah, from here I can say that yeah, we have to our next step would be whatever I is not needed. I will remove that. Like whatever I don't int out here, whatever I don't want to talk is now. Okay, I'll remove that part, and yeah, I'll put that. And yeah, from here what I wanted was yeah, simply like after this you can split your data set and then yeah, try to implement linear regression, lasso regression, ridge, elastic net regression and all. And yeah, different matrices you have to check the performance of your model. And at the end you can give your observation like what are the things you observed. I mean, which kind of model you want, which kind of suggestion you would like to give to your manager. Something like yeah, they should focus on this price segment, and this model works. I mean, engines should be at front side or rear side. Yeah, all those things. Okay.
Sir, while in that shuffle split, I mean, that for train test split, we sometimes give the test size in the train test split. Sometimes we give it in the shuffle split. What is the difference and how should it ideally be, sir?
Shuffle splitting is a good point, good thing only. I mean, see, you have 100 data points, okay, and you took the first 80 for your training and last 20 for your test purpose, okay. So what shuffle split does is like it will take 20, but it doesn't necessarily. It is not necessarily like last 20 only it will take. I mean, it can take 20 from any index, like from first index to 100 index, any index point. I mean, any 20 they can take if you set shuffle equals true, okay.
Yeah.
That's why it is useful, because let's say like in week 7 I will teach one I'll take one phase data set, okay, that from Kelly University, okay, and from that university like first 20 is the picture of first 20 data set is the picture of same person, okay, just by like just showing the face of left side, right side, or without speckles, and yeah, all those things, okay. So but the picture is of same person. In those kind of data set, if we take the let's say like if we take the last 20 data point as a test set, that won't be ideal test set. You see, I mean, let's say like we have 200 photos, then it means that we have 10 persons and each person has 20 photos. The data set is something like that only. I mean, first 20
Okay.
photos is for that particular person, then second 20 photo is for some other person. And so it means that yeah, last 20 photos is for some unique person, and all the data set, all the points are for, I mean, the same person only. So it doesn't show the complete data set.
Okay. So,
Yeah.
but this happens when you do train test split and give shuffle equal to true in that, right, sir?
Yeah. In that case, you
But
have
in
to-
case I mean, I've seen in certain codes where sir has used CV equal to shuffle split, and then he has given the test size as 0.2 in that. And there are certain other codes wherein he uses train test split, and there he gives the test size as 0.2. So that is my doubt, like where exactly to give, and I mean,
Train test
what?
split is actually a function, which means
Okay.
that when you call it once, it will give you one split, and that's the end of the story. If
Okay.
you have to keep on making splits repeatedly based on certain things, there you use shuffle split, because shuffle split itself is not a split. It doesn't split your data. It gives you a splitter.
Okay.
It gives you something that keeps splitting data, whereas train test split will do it once and that's it. So
Okay,
depending
okay.
on how you want to use it, if I want to do exactly one split and see initially how my model is doing, then I'll use train test split. But if I want to do, say, proper cross validation, where I may need to keep on doing multiple splits and at the same time make sure that each split is actually fairly different from other splits,
Okay. Okay.
that's when I'll use the shuffle split option.
Okay, so I believe there is one particular video wherein he divides it into validation set, test set, and train set. So that is where I would probably use the shuffle split.
No, it depends, and depends on how simply that can be done by both ways.
Okay, okay,
Yeah.
fine. Because
Yeah.
it's a bit confusing.
You
Where
use
do I
just
give the
train
test
test.
size?
No, test size, train size, both of them accept the same thing. Both of them are capable of shuffling. That's not really the distinction.
Okay.
The distinction is how many times you want it to be repeated.
Okay, fine, fine. Thanks.
Yeah, I got your point. I think as I understood like what you are saying. You are confused about like shuffle equals true and shuffle split.
Yeah.
So these two things are different. I mean, shuffle means what you are doing like and train test split when you have the 100 data sets and you want to make the train part and test part. So you just it's all about the thing like you want to take the only last 20, let's say you have set as a 0.2. So if you want as only 20%, last 20% or any 20 pieces from all the data set. Okay, and in shuffle split what it does is like a shuffle split, let's say you have set it as a 10 times, okay, or 5 times something. So it will do what it will do, like it's a cross validation technique actually. Shuffle split is different, okay. Shuffle equals to, that's a different thing, and that's a parameter right there, okay. But shuffle split is something like that. It is something like cross validation technique, okay.
Yes,
You
sir.
would have studied about that, okay.
Yeah, yes, sir. So it is when we have different folds that it does.
Yeah.
Fine, sir. Thank you.
Anything else? I mean, so are you guys want to go through this part, or because I think what I'm feeling like you guys are just in few previous steps only. Okay, I'll just clean it and I'll give you. Okay, that would be a better option.
So this collab would be helpful when we prepare for the OPs. So if you share this, it would be very good.
Yeah, I'll share it. And yeah, the question in OPs, they won't ask. I mean, see, in OPs, the problem is here is we are restricted. I mean, we can't ask you the questions on this type of question. I mean, to give some insights and all, these kind of questions won't be there. So yeah, the question would be something like that: calculate mean square, R2 score, and yeah, after just do some pre-processing steps we will ask you to do, and after that steps we'll ask like what is R2 score, what is that, what is adjusted R2 score. So like what is the R2 score, adjusted R2 score. So if you haven't in any way like they won't ask you about adjusted R2 score, okay, but still just learn that. Okay? Like what are the different loss of coefficient and all. Okay, so yeah, scoring is why we kept it as a negative mean squared error. We discussed it as the last time. Yeah, this keeps going through. well, you can see that like what happens like when you apply raise and lasso, then whether your score increases or decreases, something like that. Yeah. Okay, let's leave it this session for now. Okay, maybe we can discuss. Do you guys still? I'm asking like if you guys want to sort this part, I can go through that, or otherwise just I'll share the data. I mean, share this crop, share this collab only. Anyone interested? Because what I am feeling is like you guys are lagging behind. Okay, that's why I'm not getting that interest. I mean, I'm just speaking. You guys are just not answering something like that is happening currently. So, hello. Yeah, okay, we will discuss then. I'll share the collab in in more appropriate
Hello.
manner.
So, can I ask a question which is slightly unrelated, but like from the one of the topics which is discussed in like
Yeah,
week 3?
yeah, that.
Yeah. So we did the baseline models, right?
Yeah.
So what does like a dummy regressor actually do?
It is
I was a little bit confused.
yeah. So dummy regressor is something like that. Just you just create a baseline model. The thing is like let's say I would like to correct. So dummy regressor is something nothing but just like let's say create a you just a mean line, okay, something like that, or any method. Dummy regressor says that any baseline model kind of thing. Like let's say we had these much prices, and you saw that most of the prices are around 10,000. Okay, so let's say you created a model. I mean, you are just like a normal observer, and you see like almost on your Indian road, like everyone is driving that any Maruti car. Okay, so what you will do is, and I will ask, I'll the I have to just create a model, and I wanted to know the name of the car. Okay, so every time you will say yeah, what car it is, it would be a, you are just guessing something like yeah, every time you will guess like yeah, it's a Maruti car only, Maruti only. And as we can see here, like in the most of the time you will be correct only. Don't you think that? I mean,
Okay, so it basically gives you like a horizontal line, right? So if
yeah,
it's mean on the mean or the
yeah,
median,
yeah,
that is the model.
yeah,
Okay.
yeah, it is
Okay, I was a bit confused. That's
yeah.
okay.
So, or here in this model, let's say like the price is around $12,000. So you have to predict the price of the car. No, like every time you will say, I'll give you any data set. No, any new point. No, like
Okay.
I will say, yeah, this is the curve. This is it. What would be the price of car? You say 12,000. Okay, you will say like randomly
Okay.
every time you will say 12,000 only. It is something like that.
Okay.
Most of the time you will be correct only.
Okay. Okay. Thank you.
Yeah.
And how
And
are baseline models used? Are they like an initial predictors or something?
no, in the R2 score actually it is used to compare your model. Okay, in R2 score, if you see the formula, no, it is simply compares your model with the baseline model. It is something like a see. My screen is visible, no?
Yes, sir.
So in R2 score, what happens? Like there is something like this base model. Okay, so like how it is your model, like how your model is behaving with this baseline model. I mean, if R2 is going, this is let's say this is 0. Okay, so your model performance is how much? I mean, let's say this one is 1. Okay, I'm just simply trying to show it. Okay, this is your baseline model. I mean, this one, this line is your baseline model. Okay. Okay. Uh, okay, this is your baseline model. Okay, so how much your model is, how well your model is performing if you compare to baseline model. 1 minus u by v formula is there, no? So it is something like that. So if your score is somewhere between 0 to 1, so it means that yeah, your model is performing at least better than baseline model, at least better than a person like who is every time giving you the same answer. I mean, just by seeing the mean or anything. Okay.
Okay, sir.
Or
Yeah.
it is something like, and if your model is score R2 score is negative, which is also possible. I mean, many people like last time in the MLP OP, no, not in OP, yeah, MLP quiz, the question was there like, what can we expect? Like, is the I mean, R2 score can be negative or not? Something like that question was there. So yeah, very few. Yeah, question was like to get the range of R2 score. Okay. So yeah, the options was something like 0 to 1, -1 to 1, -infinity to 1. Okay. So yeah, correct answer would be -infinity to 1, because usually, yeah, in the 99.99% case, you will see that your model, your R2 score is between 0 to 1 only. But it can be practically, it can be negative also. I mean, practically, you can create a washed model, such a washed model, so that even a person who is randomly answering, I mean, every time answering the same value only. For example, here 10,000 US dollar, and your model is performing, still he is able to perform better than your model. I mean, you are creating some models and all, you are doing all these things, and that person is simply answering every time like, yeah, the car price is 10,000 US dollar, and he is able to, his accuracy is better than you. So in that case, your R2 score will be negative. Okay.
Yeah.
So yeah,
Yes, sir.
that is
Thank you.
yeah.
Can you also explain the permutation error we did, permutation test score, which we did in the same collab, I think.
Which one? I didn't get you.
Permutation test score. It is in the same section we had discussed when evaluating the dummy regressor.
Okay, I haven't seen that actually, so I can't comment on that. Okay. So permutation test, is it in week 3?
Yeah, it's in week 3. It's
Yeah.
some kind of p-value we're doing it, taking random. I didn't really understand what is happening there.
So what happens here is like a permutation test, or what it tries to do is like it generates some randomized data. Okay. And it compute that empirical p-value, something like that. Okay. But I also not very clear about that. Okay. I also need to look at that. Okay.
Okay, all right.
Yeah. So in regarding week 3, I would say like, yeah, Tuesday they have arranged the session, and the thing is like I haven't seen the contents also recently of week 3. So yeah, I also need to see that what are the things that was covered in the week 3. It was, yeah, I also need to, anything else from week 4, yeah, for earlier week also, it's okay. I mean, yeah, if you will ask some particular topics, yeah, these things covered. And yeah, the dummy regressors are, you should not use in your models, something like that. I mean, even in the sklearn also says about the dummy regressor. These things they have provided in sklearn to just, yeah, understand the models and all. Yeah, so yeah, maybe yeah, later new courses will come from, yeah, in MLP, some improvements are Kaggle competitions. How many of you are interested in Kaggle competitions and all? I mean, yeah, so actually the plan is to make that mandatory. Okay, so yeah, okay, let's discuss. Since we have 10 more minutes, yeah, we can discuss some other things also. Like, I'm related to MLP, but yeah, maybe some future prospects. Yeah, so the plan is something like that. You guys would have to go through that Kaggle competitions. I mean, there. Have you got the notification or information related to that?
No, we haven't received anything yet.
So yeah, earlier it was something like that. I mean, the last time just simple random, simple Viva happened, but this time you have to go through one Kaggle competitions also. Like that would be hosted by us only. So yeah, so and based on that Kaggle competition, you have to submit, and you have to submit your answer and all on the Kaggle board, and yeah, based on that your leaderboard ranking, and yeah, your Viva performance, and yeah, based by seeing that your collab and all, yeah, your final marks will be given to that part. I mean, that would be something like a different course only, something like that only. You will be given 1 month extra time for that, or maybe some time can be decided. That's not decided yet. I mean, 1 month or maybe 3 months, something like that. Don't know. So yeah, those things are also in the pipeline. And then yeah, in the September term, few new courses are coming.
So this would happen this term, the Kaggle competition.
Yeah, Kaggle competition will happen. Mostly, I would. Yeah, I am also assuming that yeah, this time only it will happen.
Okay.
Yeah, Kaggle competition can happen this time also. I mean, the last time we took the Viva, it was just a random Viva. So yeah, better than that. Because yeah, earlier the plan was to just do all the changes from the next term. But yeah, but this Kaggle thing can happen this time also. So and yeah, I would also suggest you guys to give your suggestions on that part. I mean, the plan was to just compress the all the week contents of MLP in yeah, let's say 5 to 6 weeks or something like that, and then yeah, in the later weeks we can just go through some collabs like this only, just like I showed you. I mean, we have a one data set, one, and yeah, we have to work. We have to use all the tools to solve the problems and all, something like that. This kind of demonstration part. So the plan is something like that currently. Let's see how it
So for
goes.
this, for the session that we had today, I would suggest that this data set and the questions be given a couple of days before, and we work on it, and then we come back to the session having done that. So then we can clear our doubts in a better way.
Yeah,
That's
that
the
would be
suggestion that I have.
Yes, sir.
Yeah.
This will be more better. Yes, sir. Yes.
Yeah, I also felt that. I mean,
Yeah, I also agree. So also like going forward, the actual plan is that we do different types of models, right? Like classification or like different models. We do that each week, right?
yeah.
Yeah, but I feel like all these models will have a lot of things in common because like the methodology, like what we followed in week 3 and 4 will be the methodology, right? So
Yeah.
we don't really have to go through all of them like as detailed as we did like these 2 weeks, and like instead do the take a data set and work on it.
That's true.
I think that would be a better idea.
Yeah, that's true, and that is what will. That is what happen. That is what will happen in later weeks. I mean, let's say till now you learned about the linear regression. Now what will happen? I mean, just you have to just replace that linear regression part to the logistic regression part. I mean, you have to replace that API. Nothing else. I mean, the similar thing will happen in the later week also. I mean, very few new concepts will be there. And if you have gone through that MLT part now, yeah, then obviously you know the concept behind that model and all. So yeah, code wise this thing will be there. And yeah, I also agree with this at this point. Yeah, that I should have covered these data sets and all earlier only. If I would have covered, if I would have shared this earlier, no, then yeah, the session would have been more interesting. I mean, at the left, like around after half, like 1.5 hours, I was thinking like, yeah, I'm only saying no one is taking interest. Yeah, and the reason is pretty simple. I mean, yeah, people are not able to, yeah.
Anything can be done in this regard?
Yeah, sorry.
So can anything be done in this regard? Can these kind of solve instructor collabs be shared 2-3 days earlier before the discussion? Can it be done?
I'm not sure about the other weeks, but yeah, I can do for mine week also. That's for sure. And mostly the plan is something like that. Now the many plans are getting changed. Actually, earlier, as I said in the last session also, like I'll take the week 4, and yeah, I used to take week 4, 7, and 11. Okay, this one KNN and K-means clustering part. Yeah, I used to take that, and some large scale data part also, like how we can handle large scale data with scale and all. Okay, I used to cover that, but like now we are changing some plans. Okay, so maybe only 2 people will cover this MLP part from here onwards. I mean, at least live session part. So yeah, there can be say options. I mean, yeah, what earlier the plan was to like we will shift to some other courses like later, but yeah, maybe it can happen something like yeah, Amrita and DJ can take future live sessions of MLP, and we will move to some new courses. I mean, some courses which will happen in BSc, something like that. So yeah, these things are. I mean, yeah, few things are changing. So that's why I can't assure about that. So yeah, if I would have been there, yeah, then yeah, in at least in MLP week 4 at least, that I'm also sure. Like last time also I saw these things only. I mean, people, I had to skip many parts, and yeah, this time also. So obviously it's better to, if I have a lot of things to cover, then it's better to share the data set and all earlier only. But yeah, I'm assuming that in later weeks they won't cover these much things. I mean, they have lesser contents only to cover in step one. Okay, any suggestion? Anyone wants to give any other suggestion? Hello, anyone?
Sir, what you said, that covering the whole content part at the first 5 weeks and then only doing practice would make more sense for this kind of a course, because
Yeah.
this is, actually machine learning practice. So we need to have more of practice. So I think that was, if we can work in maybe this course or future courses to complete the content part in the first 4 or 5 weeks and then only start on practice.
Yeah, mostly.
Do more practical stuff.
Yeah.
Yes. Actually. Yeah.
Yeah, in MLP you can like not this time, but yeah, next time definitely the pattern will be something like that only. I mean, the whole content will be covered in like 5-6 weeks, and yeah, later in each week you have one data set, and sir is just doing the solving all these things.
Right, sir. Because model selection, every time we are limited till we learn the next model. So once if the content is completed in 5 weeks, then we know which model to select. Then it becomes simpler and easier, and the understanding is better.
That's true. That's true.
No, actually, there is a risk involved with that. And this is a suggestion that comes up in many ML related courses. And what we have seen is that when it actually gets followed, that we are going to do theory for a certain time and then practice for a certain time. So it almost, gets, diminishing results. Because a far more effective way to learn this is, have a lot of coding going on in parallel with whatever you're learning.
Okay.
Because typically what happens is that, if you start working on a certain problem and then you hit a snag somewhere there and you've already finished your theory, then it becomes very difficult to go back to the books,
Okay.
Yeah. Unless you're somebody who's already, you're good with that. You can transition seamlessly between coding and studying and things like that. But that's not the case for many people.
Right. But then something like a project
initially it works very well. So for example, if we say we are going to study all models for first 4 weeks and then do Kaggle or something like that, or projects for the next 8 weeks, right? Till 6th or 7th week, it will go great. But after that, it will crash like anything. This is likely to happen.
Okay.
Yeah, these are the risks. Whatever you said, Jaidev, like these are the risks we are taking. Something like that. Like earlier, the plan was to compress in 4 weeks only. Then yeah, we are thinking something like that. How many weeks we should keep the contents and all. So yeah, whatever is said, yeah, that is also a risk. But let's see. Yeah, but one thing is good. I mean, the Kaggle competition that is happening. I mean, but yeah, we have to set the limitations. I mean, no one should use TensorFlow and all other libraries. We won't allow that. Otherwise, yeah, whoever knows the data sets, like they would have some age. But yeah, we will try to reduce that age. So yeah, those will be some private competitions also. Private kind of competitions. And how many of you are like who were familiar with data science and I mean VSQL and all? Like Jaidev, I know that he's expert. So yeah, any other person like who knows and who have worked in like data science domain? Anyone? Or everyone is just learning for the first time?
It's your first time.
Yeah. Any other person? No, I mean like it's just that like I will set my expectation something like that only. I mean that's why I'm asking. Yeah, so Jaidev, you want to complete your BSc also? I mean, yes, or something like that.
I think so. I'm not sure yet, but I mean, given the way things are progressing, I think I'll anyway stick around till I'm done because I was initially only supposed to audit this course, the foundation courses,
Okay, okay.
but I got so addicted that I thought I'll just stay back.
Yeah, in the later terms, like yeah, suppose it like and in which field your expertise is? I mean, particularly in ML.
So I specialize in building the tooling around ML systems, basically developing ML-driven software, ML as a service. So essentially making it easier for people to bring their models, run them, tune them, consume them easily, expose them properly, scale them, and all that. So I myself don't do any model building, but the infrastructure that is required to keep them running and all of that, you can call it, it's called ML ops. I do occasionally I do model building, but that's only for some specific consulting or something like that. Because model building itself is becoming very mechanical nowadays. It's very fixed set of steps that you do, and it's like I said earlier, solving this problem particularly isn't difficult. The regression problem.
Yeah.
It's the explanation and it's all of the other supplementary activities that matter a lot more. So yeah, that's what I do.
DevOps, ML ops. Yeah, new yeah, because yeah, I thought like there are two parts usually. I mean, for others, I would say that the start. This is like such a MLP course. You would. I'm saying these things because what I'm assuming like there can be a chance. There are chances like you won't meet in MLP now. So yeah, maybe let's see. Yeah. So yeah, maybe after we will meet in some other courses. So yeah, that's why I'm just saying these things. Otherwise, I would have said these things at the last of the course, like last of the week 11. I would have told these things. I mean, after MLP courses, just to try to specialize your part. I mean, whether you want to go in that image processing part and all, like okay, or you want to do your expertise in this part, NLP part, or something like that. Whatever you. So based on that only, you should select the future courses. I mean, in the September term, you would get see that speech technology, deep learning, mathematical areas in data science. Yeah, some courses related with data visualization also. Yeah, these things you will see. But yeah, you just after this MLP courses only, like you should take your understanding, like in which field you want to go. Something like that. Yeah. So yeah, that's all about today's course. I will just clean this one and I'll share this collab properly. Okay. And yeah, thanks everyone. Anyone
Thank
want?
you, sir.
Yeah, thanks. Thanks, Vivek.
Thank you, sir.
Thanks, Adi. Thanks. Hello, are you here? Please close this.